Okay, last one that needs a second part. So this is the continuation of working with common factors of polynomials. And what that really means is a common factor of every term in the polynomial. So when we did this live, we had done a few things. We talked about finding the greatest common factor of a polynomial, and the main way we did that was by using prime factorization. Now, we did talk about how weird it is to be prime factorizing with variables, but I think we took care of that and used each variable as a prime factor by itself. And then we talked about factoring a polynomial by factoring out or separating out that greatest common factor. And that's essentially undoing the distributive property. So the big idea here was that when every term in a polynomial shares a common factor, you can factor that out. And factoring out just means undoing the distributive property. So undistribute. Sounds weird, but yeah, we're undoing the distributive property. And that's pretty much because we have typically learned that the distributive property works this way. Can't see that color. When you go A times a sum, you get that. But one of the wonderful things about things being equal is that if it equals each other one way, it also equals each other this way. So we can go back and forth with the distributive property. We can keep doing it and undo it, do it and undo it. So basically when we undo it, that's when we're factoring. And factoring is super common. We do it a lot. So we started here in this section about factoring out the greatest common factor. And our examples were using 18 plus 27 because 9 is the greatest common factor. So we were able to find the greatest common factor. And right here, up at the top, not good, yeah, there we go, is how we would write it as factored. So that the 9 times 2 plus 3, that's in factored form. The 18 plus 24 is in simplified form. So generally when we simplify things, we don't want to see parentheses. So when we simplify, it's the same thing as kind of expanding, taking everything out and spreading it all out and doing everything that was being asked to do. So this was one that we did in class, and I think we did it pretty quickly, or we had a student do it. I'm sorry, I can't remember which, but we kind of took these terms and we prime factorized so we could find that greatest common factor. So we kind of broke this up into 14 times a cubed and times b. And then we said we can take this 14 and break it down into 2 and to 7. So here are our prime factors. 2 times 7 times a cubed times b. 2 times 7 times a cubed times b. And if we really wanted to be super specific, instead of writing a cubed, we could write this as a times a times a. And that might actually be easier, at least in the beginning. Especially when we have other things to compare it to. So let's take a look at this next one. This next term in the polynomial. And let's see. Let's factor this out to be 7 times a squared times b squared. And then again, to be super technical, let's call this a times a, and let's call this b times b. So our prime factors are right right here. And we might write that as 7 times A times A times B times B. And then with this last one, we can write this out as 49 times A times B cubed times C squared. And we know 49 can be broken down to 7 times 7. A is still just going to be A. B cubed, that's going to be B times B times B. And C squared is C times C. So we might write this out as 7, because these are all prime factors. There we go. So 7 times A times B times B times B times C times C. Now, I do recognize that when we were first learning about prime factorization and about exponents, probably in elementary school, 4th, 5th grade maybe, we were taught to use exponents. But I think for now, we should write these out so that we can compare and make sure we have everything that's in common. So let's just go through and compare what we have in common here. So this first term has a 2 in it. None of the other ones do. So that can't be a factor. So we move on. Let's see, this has a 7. All the other ones have a 7. So that's going to be a good thing. Okay. Then we've got some A's. Well, each one has an A. So we'll take one A. This one has a second A. This one has a second A. This one does not. So we can't take any of the next A's. Let's see. We've got a B there, a B there, and a B there. But we don't have any more B's in all the other terms. So that's as far as we can go. Our greatest common factor here is going to be 7 times AB, or 7AB. Now, we can factor this. We can start writing our factored form using this greatest common factor, 7AB. Now, everything that's left over in all of our prime factorizations, we multiply those together, because that's what's left. So what's left here is a 2 times A squared. What's left over here is an A times B. Yep, plus. And plus again. And then what's left over here, here's our A and our B, is a 7, a B squared, and a C squared. 7B squared, C squared. So we have just factored that expression. And you can prove it by multiplying that back out. So we just took what we learned about finding the greatest common factor and how to use prime factorization to do everything for us. Because prime factorization is wonderful. Let's take a look at this one. Get rid of this here. Let's prime factorize. And sometimes we may not need to go all the way to prime numbers, because once we start seeing some things in common, we'll be okay. Like for instance, we might be able to take this 12 just to 3 and 4. We know that 4 can be factored further. And I'm going to call this y to the 4th. But I'm still going to break it down. So I'm going to call this 3 times 4 times x times y times y times y times y. Okay? Beware of our signs. I'm just going to make sure we're aware of them for our last step. Factor this into 21 times x squared times y to the 5th Oh yeah, and then we've got that z thing in there too. 21, that can be factored into 3 and 7, both of which are prime numbers, so we don't have to worry about that. X squared is the same thing as x times x. I'm not going to write out all these y's. That's a lot of y's. Y, 2, 3, 4, 5. And then don't forget this z. So we write this out as 3 times 7 times x times x times y times y times y times y times y times z. Okay. Last one. These are big numbers too. This can be 36 times x times y cubed. Well, 36, how do we want to factor that down? Let's factor it down as 6 times 6. Because then we can do this is 2 times 3 and this is 2 times 3. Our x is still an x, and that y is still y times y times y. I probably should highlight these factors here. Just so you know where they're coming from and you don't think that I'm pulling something over on you, because I would never do that. Not on purpose. So this is now, we break this down as 2 times 2 times 3 times 3 times x times y times y times y. Okay, done with the prime factorization. Now, let's look to see what we have in common. Okay, so here we have a 3. They all have a 3. Excellent. Okay, this one has a 4, which also could be a 2 and a 2. But this second one doesn't have any 2's at all. The third one does, but since the second one doesn't, we can't count it. So let's see, this first one now has an x moving along. So we can get an x. That one's got 2 x's, but we can only take 1. And that one's got 1 x. Now, let's see. I've got a y. This has a y. This has a y. This has another y. Another y. And another y. And another y. And another y. And another y. Oh, I'm out of y's over here on the end, so I kind of got to stop. And I don't have any z's anywhere else. So, my greatest common factor is 3 times x times y times y times y. So 3xy cubed. That's our greatest common factor. So when I write this out, I throw it here in the beginning, and then start multiplying everything else that's left over. I have a 4 and a y, so 4y. Then a minus sign, that's why I most noticed that up top, times, let's see, minus 7 times x times y squared times z. So that's a 7x y squared z. And then plus 2 and 2 and 3, that's 12. Just 12, plain old 12. That's awesome. So we worked this out to be 3xy cubed times the quantity 4y minus 7xy squared z plus 12. You think that's easy to say? It isn't. Okay, I think there we have maybe 1 or 2 more examples, and I'll get those for you on the rebound.